Okay, guys, let's begin our lesson. We're still on Unit 7. We are now on Lesson 5. Today we're going to begin our first lesson on graphing rational expressions. Now we're only going to be talking about a special kind today that look like the form I've got up there on the board. But we'll also be talking about other kinds of rational expressions and how to graph those as well. But for today, we're just focusing on this. It doesn't. I put a squared here, but I should have actually put an n because it could really be any power. Okay. All right. So the first thing I would like us to do is just to kind of get a cursory glance at what these types of functions would look like. So we're going to start by graphing this one, and then after that I want to graph one that's kind of like it. It looks like that. Okay, so to get a graph going of these things, I'm going to make an x and y table. All right, I'm going to go ahead and I'm going to pick, let's say, maybe like 3. I'll do -3, -2, -1. Now, usually you would think I'd go to 0 at this point, but I'm actually not going to. I'm gonna pick some other numbers. I'm gonna pick 0.1, -0.1. I'm also gonna pick -0.01. There's a reason for that. I'm also gonna pick 0, and then I'm gonna do the same thing for all the positives: 0.01, 0.1, 1, 2, and 3. Okay? So let's go ahead and see what that would look like. Now, if I plug in these numbers, -3, if I plug in -3, I get -1/3, which is about -0.333. It just kind of keeps going. It's a pretty small number. If I plug in -2, I'm going to get -0.5. And then if I plug in -1, I'm going to get -1. So the numbers are getting a little bit more negative here, as you can see. I'm going to plug in -0.1. Now, don't stress about it, but if you've got a calculator, basically, and you plugged in -0.1, you would do 1 divided by -0.1, and what you would get is -10. If you plugged in -0.01, 1 divided by -0.01 would actually be -100. So that's really negative, right? So we started at a small negative number, and they just kind of get really big quick. Now, if I plug in 0, I have 1 over 0, and that's undefined. Okay, you can't have an answer there. Now, the same thing's going to happen here on the other side, so I'm going to go ahead and just copy these in. All right, and I'm going to go ahead and make a graph of this thing. All right. My x-axis, I need to go out to 3. My y-axis, even though it goes up to 100, I'm not going to go that high. I'm not going to graph those ones. They're too big. I think I'm just going to go up to 10. Okay. So my first point I'm going to plot is -3 and -3.3. So that's going to be really close to the x-axis. -2 is at -0.5, a little bit, still pretty dang close to the x-axis. -1 is going to be at -1. -0.1, which is really close to the y-axis, is going to be down here at -10. So we had a major change there. What's happening is that if I connect these dots, I can see that it's going like this. It's starting to bend down, and by the time we get over here, it shoots down all of a sudden. So that's what it's going to look like. Okay. Now, the reason that 0 is undefined is because in the center here, we actually have a vertical asymptote. This line cannot touch the line. It gets closer and closer to that yellow line, but it will never actually get there. And we actually have a horizontal asymptote going the other way. Oops. going this way, the line is trying to get closer and closer to the green line as well. So we have a horizontal asymptote and a vertical asymptote, but we're not done graphing this yet. There's still more to be done. I need to do the positives now. So at point 1, which is really close to the y-axis, we're going to be up 10. At 1, we're going to be at 1. At 2, we're going to be at 0.5. And at 3, we're going to be at 0.3. So it's the same shape. It's just like a reflected image, if you will. This is what the graph of 1 over x looks like. Okay? All right, so that's this one. We got that one taken care of. Let's talk about the graph of 1 over x squared. So I think I'll just start with -2 this time. -1. Let's do -0.1, 0, 0.1, -1. I'm sorry, +1. Erase that. +1 and +2. Okay. So if I plug in -2, it's going to be a little bit different this time because we're going to square it first. And so 1 over 4 is going to be 0.25. If I plug in -1, when I square it, it becomes a +1. So notice that even though I'm plugging in negatives, I'm getting positive answers because of the square. If I plug in 0.1, I'm going to have to use my calculator for that. Just a second. I get 100, so I get a really big number for that. If I plug in 0, I get undefined again. Now, if I plug in these other numbers, I'm actually going to get the same exact answers again because of the squaring. The only difference between these ones and these ones is plugging in a negative, but when you square it, the negative doesn't matter. So you get the same numbers repeated there. Okay, now let's see what that's going to look like when we graph it then. This time, I guess I'll pretend to go up to 100, although I'm not going to actually draw the graph to scale. I'll put 1 here. Okay, so let's see what this looks like then. At -2, we're at +0.25, so we're actually above the x-axis. At -1, we're at +1. And then at -0.1, which is really close to the y-axis on the left, we're all the way up here at 100. So now we have the same shape we had before, but it's up here. On the rest of it, at 0.1, a little bit to the right of the y-axis, we're going to be all the way up here at 100. 1 is here, and then 2 is 0.25. It looks like this. And so here's what I want you guys to realize from this discussion here is the following. And here's what you guys want to be writing. If we have a function, which is y 1 over x, well, I'm going to put an a up here, but just sit tight for now. We can pretend it's 1. If we have a function a over x to the n power, what we just discovered is this, is that when we had an odd power, the shape of our graph looked like this. But when I had an even power, the shape of my graph looked like this, because it cancels out the negatives. And so instead of ending up with negative y values down here, all of our y values just go right back up here to the top. So that's what we discovered. Now, that's if n is odd and n is even. But what if I put a negative in here? You guys know that when you put a negative in the front, right, that flips things over. So if I put a negative in the front, this whole graph would flip over, and it would look like this for that one, right? That's if my a the number on top is negative. How about this one over here? If I flipped that one over with a negative a, what would it look like? It would look like this. So we have 4 possibilities, and it's based on 2 things. It's based on whether the power is even or odd, and whether a is positive or negative. Okay? When a is positive and n is odd, it looks like this. When a is positive and n is even, it looks like this. But if a is negative, the odd one will look like this. Or if a is negative, then the even one will look like this. It flips them upside down. So we have 4 possibilities. So I'm going to give you guys an example to do and copy here. So let's go ahead and take a look at example 1. Graph the function. All right. So suppose I have y is equal to negative 3 over x to the 4th power. Okay. So what I want you guys to notice here is that the power is even. The number on top, which I've called the a, is negative. Right? So, oops. Where did it go? Right there. I have a negative a and an even power. My graph is going to look like this then. Okay? And that's pretty much it. Pretty simple, huh? We're going to add some stuff to it in a minute. But for now, this graph would look roughly something like this. There we go. The horizontal asymptote would be here, and the vertical asymptote would be here on the x and y axis. Okay? In case you guys don't remember what an asymptote is, it's a line that your graph approaches but never reaches. Okay? So I'm going to give you guys a student practice at this time. I want you guys to see if you guys can graph this one. Five over x squared. What would you do with that? Go ahead and pause the video. Take about a minute to try it out, and then unpause the video. Okay, so what you guys should have noticed is that the power is even, and the top number is positive. When that happens, you would have this shape. Okay, so it would look something like that. All right, now we're gonna add some stuff to the mix here. Where was I? We're going to talk about transformations. So B. So let's talk about graphing this. Now you guys remember that when you subtract a number from x on the inside, that moves your graph to the right, correct? And whenever you add a number to your function, that shifts your graph up and down, right? So all this is going to be doing is shifting our graph around, okay? Now what they actually end up becoming is, usually our vertical asymptote was this vertical line here in the middle. Let me come back to it. This was my vertical asymptote, right? But if I were to shift the graph over to the right, then my vertical asymptote is going to move over too, correct? Now the equation of a vertical line is always x equals whatever the x value is there. In this case, it would be 0. So coming back over here to our problem, by shifting it, this basically just tells you what your vertical asymptote is going to be. My vertical asymptote will be x equals h. And I want you to notice that once again, just like always, it will end up being the opposite sign from what was here because of that negative. It flips it. So my vertical asymptote will be h. This number here, which shifts it up and down, that will change, that will give you your horizontal asymptote. Oops. Okay, so let's talk about why that is. Usually your horizontal asymptote is right here, and the equation of that line would be a y equals, because horizontal lines have a y equals form, and it's at y equals 0 because it's on the y equals 0 line. So it's y equals 0. But if you were to shift your graph up and down, like say up, now your asymptote will be up here. So basically, this number that we're adding on to our function shifts our graph up, and that will basically tell you what your horizontal asymptote is. So your horizontal asymptote will be whatever number that is. So since this shifts us right, that tells us our vertical asymptote. Since this shifts us up, that will tell us our horizontal asymptote. Okay? And these two things put together, the N and the A, those two things put together, they tell you the shape. Is it like this? Is it like this? No. Those four possibilities we had in the last slide. I don't think I'm going to try to recreate the whole box here, but I'll just put here, it tells us our shape. Okay, so there you go. So let me demonstrate how to graph one of these things here. Okay, let's go ahead and do an example. Let's say I wanted to graph this. The first thing you're going to want to do is identify your horizontal asymptote and your vertical asymptote. Vertical asymptotes are always of the form x equals some number. Horizontal asymptotes are always of the form y equals some number. So let's see what they are. I told you guys that this number here tells you what your vertical asymptote will be, but you got to remember to do the opposite sign. So my vertical asymptote will be x equals a positive 1. My horizontal asymptote, as I told you guys in the last slide, will always be this number, the 5. And it's not the opposite sign, it's just as it is. So I have a vertical asymptote at x equals 1, and I have a horizontal asymptote at y equals 5. That's the first thing you'll want to do. Now that we know what those are, we're ready. Let's go ahead and graph those. So I have a vertical asymptote at x equals 1. So here's x equals 1, and I'm going to draw a vertical line there. And then I'm going to draw my horizontal asymptote at y equals 5. So after you identify your horizontal and your vertical asymptotes, you're going to graph them. The next thing you're going to do after that is you're going to look at your A to decide whether it's positive or negative, and your power to determine whether it's even or odd. Now in this case, I have a positive A value and an odd power. So I'm going to go back to my chart here. When I have a positive A and an odd power, my graph will look like this, where these lines are the asymptotes, right? So let's go back to our picture. Here's my asymptote. So I'm going to draw that shape so it hugs up against those asymptotes just like that. And so that's what that graph would look like. Let's do another one. Okay, so let's identify our vertical asymptote. Vertical asymptotes are of the form x equals, and it's this number here, but the opposite of it. So my vertical asymptote is x equals -2. Let's find our horizontal asymptote. Horizontal asymptotes are the form y equals, and it comes from this number here, and it's going to be the same sign as that number, so it's -4. So I've got a vertical asymptote at -2 and a horizontal asymptote at -4. Let's go ahead and graph that. Vertical asymptote at 2, -2. Horizontal asymptote at 4. So there's my asymptotes. Next, we're going to look at the shape. See if you can figure out what this shape would be. Since the power is even and the a value is a negative value, looks like this and this. That's it. Okay, let's do another example. Suppose I wanted you guys to graph this one. So what you'll notice here is that we're missing something, right? Don't we usually have the x in parentheses with a number here next to it? Well, if you're missing that number, just like in every other problem we've done this year, anytime you're missing an h or a k, it's 0, okay? So we're going to put a 0 there. Okay, so let's go ahead and identify our vertical asymptote. I'll wait a little bit, give you guys a chance to see if you can figure out what that is. First thing you want to ask yourself, is it x equals or y equals? It's x equals. The next thing you want to do is figure out what's the number that it matches with over there on the equation. It's 0. It's this number here. Now we want to do our horizontal asymptote. See if you can do that one. Horizontal asymptote is y equals, right? And it's this number here. All right, so now we're ready to graph this thing. So my vertical asymptote is at x equals 0. That's right here. That's just the y-axis. My horizontal asymptote is at y equals 2. Okay, so I'm going to try to color code these again just so that we can see them a little better. But there's my asymptotes. X equals 0 and y equals 2. Now I want you guys to go ahead and take one and see if you can figure out the shape and put it on there. So since we have a positive a value and an even power, it would look like this. And there's our graph. Okay. And just so you guys know, I think I'll stop there with the examples and let you guys practice a little bit. But just so you know, same thing applies if you don't have the k value there. So if you're missing a k value, that would also be +0. Okay? All right. So let me go ahead and put up a few student practices for you, and then I'll let you guys take a moment to work on them. I'm going to change that one up a little bit. Okay, there you go. So go ahead and pause the video there. I think 5 minutes should be good enough for that. So do as many as you can in the 5 minutes and then unpause the video and you'll see the answers displayed. Okay, so there's your guys' solutions there. For number 1, the vertical asymptote was -1, the horizontal asymptote was -2, and your shape, your green lines are the graph shape that would look like that. Number 2, your horizontal asymptote was 1, your vertical was at 0, and the shape would look like that. Finally, number 3, your vertical asymptote was at positive 2. Your horizontal asymptote was 0 because it wasn't there, right? And the shape would be having the curve up here on the left and the curve down here on the bottom right. Okay? Okay, so now I don't want you guys to write this. I would like you guys just to watch. So we have here a graph of one. As you can see, it's got a vertical asymptote here at 5. It's got a horizontal asymptote here at -3. So now I want to draw to your guys' memory something here. You remember this fun stuff over here? Okay. What is the limit of my function, which is, we're just going to call it y here for a minute. What is the limit of my function as x approaches infinity? Now let's remember what that means. So x approaching infinity means that we are going to the right, because it's positive infinity. We're going to the right. X is about going left and right, correct? So if that's the case, if x can move left or x can move right and it's going to infinity, the positive value must be going to the right forever. So x approaching infinity means that we're going to the right forever. So follow my arrows here. Imagine a little dot moving along this green line, and it's going to go to the right forever. Okay, now I have to stop there because it's getting in the way of the words, but just imagine it just keeps going that way. What goes over here is the y value we are approaching. Now remember, you don't need to write this. I'm going to make it easier for you in a minute. But what goes here is the y value that we're approaching. What y value is it approaching? In other words, how far down is this line going to go as we go to infinity? Well, since it can't pass this asymptote, it's getting closer and closer to that asymptote, and that's at -3, right? So what's happening here, as x goes to the right forever, I'm approaching a y value of -3, the horizontal asymptote. The same thing is happening on the left side of the graph. So if I were to say to you guys, what is the limit as x approaches -infinity? That means I'm moving to the left forever. But as I move to the left, that line's getting closer and closer to that asymptote. So as I go to the left forever, we're getting closer and closer, but never passing that horizontal asymptote, which is -3. So here's what I would like you guys to write. Okay? For functions of the form y equals a over x minus h to the nth power plus k, the limit as x goes to the left and the limit as x goes to the right forever, for either one of them, is just going to be whatever that horizontal asymptote. And up here, which one of these letters represents the horizontal asymptote? It's k. Okay, so that's another type of question I'll be asking you. I would just make this little note too. It represents your horizontal asymptote. So the takeaway here is the limit of your function as x goes to positive or negative infinity is k, the horizontal asymptote. So let me give you an example, see what this question might look like. So suppose I gave you guys this. Suppose I said that y is equal to 2 over x minus 5 squared plus 3. Okay? And I said to you, what is the limit as x approaches infinity for this particular function, which we'll call y? Well, here's the long way to answer it. The long way to answer is to graph it. Vertical asymptote at -5, actually positive 5. Horizontal asymptote at +3. Even power, positive, looks like this. And as I go to the right forever, I'm getting closer and closer to my horizontal asymptote, which is 3. Or you could just not graph it at all and jump straight to the answer. Okay? So the limit of this function as x goes to infinity is 3. Pretty simple, not too bad. And the same thing would apply if I were to make this a negative infinity, because it's going to approach 3 on the other side also. Okay? And I think we'll go ahead and stop the lesson there. You guys can go and do your homework. But beyond that, we'll see you guys on Monday. Have a good one.